this video, I'm going to discuss about this problem, which is from the Codeforces round 952. The problem is sixth one, the final boss. So let me get straight into the problem statement, and later I'll make you understand the problem statement first, and later I'll jump into the solution part of it. So basically, when I read through the problem statement, it says that we are facing a final boss in a video game. The boss has an health hedge, and it your character, I mean, the boss has health hedge, and there is one separate character, which is my character. It has n attacks, and it says that the ith attack deals with AI damage to the boss but has a cooldown of CI turns. Means that the next turn you can use this attack is turn X plus CI. If your current turn is X, each turn you can use all the attacks that are not currently on the cooldown all at once. If all the attacks are on the cooldown, you do nothing for that turn and skip to the next turn. I see. Initially, all the attacks are not on cooldown, and how many attacks will it take to beat the boss? And boss is beaten when its health is zero or less. So basically, let me go through the input parameters also, and and afterwards I'll make you understand this problem. So it says that in the input parameters we have been given an h and n. H is the health of the boss, and n is the number of attacks, and each attack has this many damage powers and respective cooldown periods. I see. So we need to find the minimum number of attacks, not just the how many turns. We need to find the minimum number of turns. Sorry, not the attacks. Minimum number of turns required to beat the boss. So basically, let me just try to explain the problem statement. So it says that if you see here, you are facing a final boss in your favorite video game, and it has health hedge. So the boss has health hedge. There is one separate character boss, and it has health as H, and there is one separate character for us, and my character has n attacks, 1 2 3, so until n attacks, and each attack has a damage power AI, and it has a cooldown period of CI, right? Cooldown period of CI. Basically, it says that let's say the boss health is somewhat around 5, and I have two attacks, and damage power of both the attack. One attack is 2, and damage power of another attack is 1. So if I use this attack, then the health will be subtracted by the damage power. It will become 3. Or if I use this one, then health will be subtracted by 1, and it will become 4. And cooldown period, let's say I keep it as 2 comma 1 itself. So cooldown period of this attack is 2, this attack is 1, which means let's say in first turn 1, health of the boss is 5. You are using both, let's say you are using both the attacks. So you are using both the attacks to 1 damage, total damage will be 3, and finally what will be the boss health is 5 minus 3, which is 2. So boss health is 2 in the turn 2. Cooldown period of this one is 2, which means that it can be available only if the attack is turn X plus CI, which means that it has to wait after two turns. Like first turn it has been used, second turn it can't be used, and then in once again in third turn only this one can be used, and in second turn it can't be used. But the cooldown period of this one is 1, which means that it can be used in the next turn. So damage will be 1, and final boss length will be 1, and in turn 3 attacks this one can be used, and this also can be used. So 2 plus 1, which is 3, and the boss health will be 1 minus 3, which is minus 2. So it says that here, if the boss attack is boss health becomes 0 or less, then the boss dies. So number of turns you can use is 3, right? And see, and also I want you to note that in a turn you should be using all the attacks available. It's not that you will not use one attack, and then let's say you have all these attacks, you will use this attack, this attack, this attack, but you will not use this attack, you'll use this one. Why are you saving this attack? Why? Because since we have to minimize the number of turns, not the number of attacks, we have to minimize the number of turns. So it will be better if we use all the attacks in a single turn and reduce the boss health as much as possible. Boss health as much as possible. So it will be better to no, use all the attacks in a turn which are is available. So that's the basically the understanding on the problem statement. If you want to know which concept we can use here, then this is basically can be solved by using the binary search. How, I will explain at once. Basically, binary search, in order to before telling this the how binary search is used here, we need to know the why the binary search is used in this problem. Why binary search? What was the identification mentioned in this problem now which led me to know that binary search can be used here? Why? Because the binary search is used whenever the function is monotonous. Function is monotonous. Binary search is used whenever the function is monotonous. What is kind of a monotonous function? Monotonous function are like that. Let's say we have a graph. It will be behavior of monotonous function will be something for a period of time, and there will be some change, and then after that period of time, for the permanent change, it will be some other behavior. I'll repeat it again. See, from the birth of that function, it will be one behavior b1. Behavior is b1 here, and suddenly after some period, like after some, we will call it as a barrier. After some barrier can be of unit distance or no change, or it can be of some change. After some barrier, the behavior of the function is changed to b2, and it remains b2 forever. Forever, it remains b2 forever. See, this is the definition of kind of a monotonous function. As in my case, I defined it like this in my terms. So it will be of some behavior before, and after some barrier, the behavior of the function will be changed to b2. For example, if you want to see the few monotonous function example, yeah, this kind of like a monotonous function. See, behavior of the function is something else, and after some barrier it became something else. Behavior of the function is something else, after some barrier it became something else, again after some barrier it became something else. Like if we place this is the end of the function, and it from birth it is something else, until it dies it is something else, like that. It goes on like that, monotonous function. So why, what made me to conclude that this function is monotonous? If you see here in turn 1, if you see in turn 1, are you able to are you able to tell that whether the boss can be died or not by using all the shots you have been allotted to? In this case, boss health reduced to 2, which is not 0, which is greater than 0. I can say that boss doesn't die here, so I can tell it as false, which means boss doesn't die. In the second turn, if we see here, boss health becomes 1. Here also in this case, let me change the color of the pen. So here also boss doesn't die, so false. In the third case, health becomes minus 2, which means that boss definitely dies, which means boss can be killed, which is 3. But if you see, let's say I am going on to use the next turn, and assuming that the boss health continues minus 2, and what the since the cooldown period of this bullet is 2, so it can't be used in the next turn, but this bullet can be used. So I can damage, overall damage is 1, which is equals to minus 2 minus 1, which is minus 3. Boss health becomes minus 3. Still, w- what can I say it from here? Whether boss is alive or not, boss health is still less than 0, which means boss health is true. So if you see here, if you see here, the boss health was false before, which means the boss didn't die, and after some barrier, boss is killed forever. Like how much ever turns you repeat, boss is always dead. So that's what I want to show it here. So similarly, in this kind of monotonous function, boss is not dead, it is false, it has some health hedge, and after some barrier, after some particular turn, boss is killed, which makes it true. So this can be solved using this one. This can be solved using binary search. And how will I use binary search? I'll explain. So if you see, since I have concluded that this is solved by using binary search, how will you use binary search is that basically in any binary search problem, what will you have? Like binary search should be having three parameters. One is low, another one is mid, and next is high. So basic pseudocode of the binary search goes like this: low is the minimum value it is assigned to, high is the maximum possible value it is assigned to, and it will have a while low is less than or equals to, till low is less than or equals to high, loop is running, and I will calculate the mid by low plus high divided by 2. And what else? Sorry, low plus high divided by 2. And then, and if something happens, I need to go high minus 1. I need to assign the mid to high minus 1, and sorry, high to mid minus 1, or else if something else happen, I need to assign low to mid plus 1. Basically, in the binary search, I need a condition to find the mid, and after finding the mid, I need one more condition to move either to the right hand side or to the left hand side. First is the condition to find the mid, the next is the condition either to move left or right. That's what the two main base condition for a binary search. Why left or right? If you move left, one of the array is eliminated and you are halving the array, or if you move left, I mean if you move right, this left one is eliminated. If you move left, right one is eliminated, and it goes on, complexity comes out to be log n. So in this case, I will quickly tell you what are all the uh, low and high. Low can be as low as the health of the boss health is 1, and attack, if it is attack is also 1, then it will take one turn to completely defeat the boss. So here the low is 1. And what about the high? High is health of the boss is 2 into 10 power 5. Let's say my damage or the maximum possible turns I will be taking is, let's say, my attack is 1, my attack is 1, but my cooldown time, if I'm saying the attack is 1 in any case, which means attack of all the this one is 1 1 1 1 1. Okay, now if the attack is 1 and the cooldown period is 210 power 5, cooldown period is 210 power 5, and with the health is 210 power 5, so maximum possible how much it will go is 2 into 10 power 5 into 2 into 10 power 5. This much turns I will be getting, which is 4 into 10 power 10 for the rough possibility, 2 into 10 power 11. Okay, this is low, this is high, and mid you will be calculating, which is low plus high divided by 2, or in order to avoid integer overflow you can write it as high minus low by 2 plus high. Okay, and so let's say we have defined mid. Mid is done. Once the low and high is found out, mid is calculated by the half low plus high divided by 2, and condition to move left and right. So the condition to move left and right is, let's say I'm defining one condition after finding the mid something. If if like, what is the mid is giving? The mid is giving some turn number. Mid is giving some turn number. If that if that turn, let's say solve of turn, is able to kill the boss, let's say what is in our case was false in first turn, false in second turn. Let me just once again cross check. True in third turn, right? Yeah, false in first turn, false in second turn, true in third turn, true in fourth turn, true in fifth turn. Let's say by halving the array you are coming to this part. Sorry, let me just undo it. I say I have one more true in sixth turn. Okay, and by halving the array, true in seventh turn also. What is 7 by 2 is 3.5, 3.5. True in eighth turn. I just want to tell you one thing. So let's say by halving the array, if I'm coming here, so if the solve of the turn number comes out to be possible answer, like if this particular turn is able to kill the boss, and I will tell you how will you find whether you are able to kill the boss or not. Let's say I am able to kill the boss, then which side you will be moving, either to the left or right. Obviously by seeing this thing you can say that if you are able to kill the boss you need to move towards the left, so that there is a possible candidate in the left, which is the minimum turn number where I can kill the boss or not. So let's say if you are getting mid as here and the solve function fails, let's say this is for if you are able to kill the boss, not about the else case. If you are not able to kill the boss, then you should move towards the right. So basically our second job is also done with how to move left and right. Only thing that is left is to find the solution for the solve function in that particular turn, how whether you will be able to kill the boss or not. So what was that? In our case the damage was 2-1, cooldown period is also 2-1. So in that turn, particular turn, let's say the turn is 5, and health of the boss is something around 50. What is the, whether if you are able to kill the boss or not, you need to find the overall damage you will be causing to the boss starting from turn 1 to turn number 5, our desired number. So how will you do is, let's say as we know in this case, if the damage is 2 in the first turn, in the second turn the damage of that particular 2 will be 0, while it can't act, and in the third turn it will be 2, and in the fourth turn it can't act, and in the fifth turn is again 2, right? So what about this one? It is always 1 plus 1 plus 1 plus 1 plus 1. So what is this thing? 2 4 6, and this one is 5, and total damage is 11, right? Damage is 11. So the overall damage will be causing from 1 to turn 5 is 11. So subtract 50 minus 5, sorry, 50 minus 11, and it will come some around. Whether you will be able to kill the boss or not, you can find it out. But how will you do this thing? Since, see, wrote it in this case. Why? Because it was quite easy to identify. So what you can do is just keep that damage power and multiply by current turn number by cooldown period. Let's say damage is D into current turn number by cooldown period. If it is perfectly divisible, multiply by it. If it is not, add 1 to it. This you need to cross check. If it is perfectly divisible, like if it is 4, turn number 4, 4 by 2 is 2 plus 1. Sorry, I need to reconnect. Um, so yeah, if it is perfectly divisible, no need to add this one. If it is not, just add this one. You will get the damage for this one, overall damage from turn 1 to that particular turn number, and add that all the damage d2 and subtract it from the health of the boss, and you will be getting whether it is able to kill the boss in that particular turn or not. That's it. In the code wise, I will be attaching the solution link in that description. So thanks for watching this video. Thank you. Bye.